Welcome to the lab. I got to get started on this FG501A so I can finish up the calibration on the FG507 that's back there. Needed a second function generator, so this one's in pretty rough shape. These caps have gotten hot and a few other things. This is similar to the way the other one looked when I got started there, so we'll do the same repairs on here, run this through a calibration process so it's good to go, and then I'll be able to finish up part 2 of the FG507. So I've already cleaned the switches, got everything done, cleaned up the contacts on the back of the board, so I'm into replacing these capacitors here real quick and then running this through a calibration. There's a lot less adjustment points on this one than there is on this one, on that guy, because he doesn't have the sweep board. So they're essentially the same. So this line actually divides the two instruments. So these are essentially an identical instrument. This is the sweeping side of the 507. So makes him a little bit more involved than him, but we'll get started on the 501. Let's see if we can get it restored. Okay, well, I've got the new capacitors installed. There's everything looks good on the board. They shrunk down a lot. These are higher value, same voltage, but a little bit higher capacitance or better. So they shrunk quite a bit in terms of physical size. Haven't even cleaned the legs off. Haven't even trimmed the legs on the back. They're all still hanging out, and I haven't cleaned all the flux off, so that's next. Let me reposition the camera, get all the legs trimmed, and then I'll clean the flux. Okay, I've got all the leads trimmed. I'm ready to clean the flux. This is just a toothbrush with 99.9% isopropyl on it. If any of the joints break, you can be a little aggressive on a board. Nope, missed the lead. If any of the joints break when you're pieces come off or joints break or anything like that while you're cleaning the flux like this, that would have been an unreliable joint anyway, so it is something that needs to be addressed. I also replaced like I did in the 507, I replaced the timing op-amp sockets. This board has the same terrible sockets, so we'll see if I have to replace any more of those, but I did replace the timing ones for good measure. Alright, let me move some stuff around on the bench, and then we'll give it a smoke test, see if anything blows up on us. Okay, I've got the scope on, I've got the test frame hooked up, and I've got you guys pointed if there's going to be any excitement. Ooh, that's loose. Have to see about that. Nah, it's not moving left and right, so have to address that here in a minute, but let's see if we're good. Unfortunately, no excitement. or fortunately. I have a nice sine wave on the scope. Everything looks good. All right, I'll be back when I test the ranges. This is going to take a bit. Okay, I've got everything set up to do the alignment on the function generator. Hopefully this should be pretty quick so we can get back to the sweeping function generator. Everything's set on the front range for preliminaries. Got the voltmeter hooked up. Nope, I got to move this. So I need to do the plus 15 volt supply first. The plus 15 volt test point is right there. Here's our potentiometer. Right here. So I'll move you guys up to the meter so you can actually see the adjustment. Alright, we're looking for a positive 15 volts, and I need to be within plus minus 0.1%. 14.999. That will be good enough. Negative 15 volts. $15,000 works for me. Our target is better than 15.015, so we are plenty good there. Next one up is the plus 5 volt rail. There we go. This is no adjustment. This is just a check. The digital voltmeter must indicate a readout under 5.025. We're at 5.020, so we're good there. So we need to check the 20 volts. Well, that's good enough for plus 20 volts. 19.9 and 20.1 are the swing. Negative 20 volt supply. Oh, nope, that's... where's the test point? Oh. Negative 20.1, so that's fine. Everything is good there. Wonderful. So that's our supply rails. Okay, I'm getting ready to do the dial alignment. So what I need to do is I need to move the potentiometer just until the... So I'm watching the scope. Move the potentiometer just until the waveform stops moving. I have it loosened up from the control. So there it's moving like that. There, it just stopped. stop at the center of the graticule. Now I'm going to just bring this down right there. Make sure the knob is on exactly 20. It is. That just stopped. Loosely tighten the Allen key. Now what we're going to do, back this off to 18. Rotate it till it stops, just stops, and make sure it's within a half a division of 20, which it is, so the dial's now aligned. Finish tightening that. Back it off to 18 again. Actually, that is perfectly aligned at 20. So we'll go to 18. Trace just stopped moving. Yeah, that's right on the money. So that looks good. Do one more time just to double check. Actually, let me zoom. Just getting a better zoomed in view of when it was stopped. So we'll go to 18. Yeah, right there. So there we go. That's good. Okay, for doing the offsets, I've set the scope up a little bit differently. I'm at 0.5, and then I used a variable to make it 4 divisions of display. After that, I unplugged the scope, found the center with the amplifier on ground, and then I turned it over to DC and plugged it in. So I'm going to do the offset, but instead of being real narrow, this is giving me a better display to line up. So I want to bring the sine wave down just a little bit. So I need 2201. Okay, there we go. It's also to note that you do need the scope in DC to do this, not AC. AC won't work. And now we got to do the same thing for the sine wave. Well, let me show you that here. So what we'll do, shrink this a little bit. Okay, there's my 4 divisions. So we'll flip this to DC, or ground, and you'll notice the line is biased below the center. So we'll bring this right back to center. Now I know I have 4 divisions of display going into the scope. So we'll flip this back to DC. Now I'm biased up, so I need to bring it down just a little bit. Which, that is 1104. And that's on the aux board. Right here. And there's my, a little more. There's my sine wave offset. All right, cool. All right, we have to do distortion again, so let me get the AA501 set up, and then I will be right back. Okay, for sine wave distortion, there is one thing to note. It says the preliminary adjustments, but then it only says the only exception is amplitude is clockwise. Preliminary adjustments have it on a square wave. You need to do the harmonic distortion on a sine wave. We're adjusting the sine wave distortion, so make sure it's on sine wave. Okay, I have you guys zoomed into the 501. I'm going to adjust 1412, 1511, and 1421 for minimum reading on the analyzer. So I had a feeling we were going to need to test. We were going to need to adjust the THD because the sine wave looked kind of funky. Had some weird peaking on the analyzer. Let me move back over to the scope and I can... It just had some weird waveforms. So let me... There's my adjustments. All right. All right, so here we go. There's the bottom there. There we go. Okay, now we're going back up. It's coming down quite a bit. This is good. This was very, very far out of adjustment. All right, we're down to 0.35%. Still going down. There we go. Wow. This was way out. Oh, we're under spec. If I remember the spec right, it's 0.25% total harmonic distortion, and we just hit it. I wasn't sure I was going to be... I thought there was going to be more work to do. I didn't think this was going to tune this well. Because we started at 265, so... 2.65. We're at 0.1 now. And still going. All I've done is the same adjustments. Just keep going through the same set of 3. Wow. I didn't expect it to get this good. Well, from being at 2.6% THD to 0.141% THD, I will take that. That's impressive. I'll have to take the bottom off of the enclosure for this one. Oh, wait, no. Ooh, this one's going to be hard to get to. Okay. Be right back. All right, fortunately I had grabbers that worked. So I need to adjust this now right here for a meter reading of 0. There we go. Show you guys what the meter says. There we go. Okay, we're back to the bottom dial SimCal 1441. I adjusted the, also make it back to a sine wave. Adjusting the frequency to 1, 10 to the second, 1441 for a minimal reading. I'll leave it as a square wave and we'll see what we can do. Yeah, not changing at all, so it does need to be on the sine wave. There we go. Alright, now I'll get set up for the offset adjusts, and then I'll be right back. Sorry about that. We had a couple of audio clips that didn't pull in the audio right, so I'm having to do a voiceover in post. Essentially what we're doing in this clip is we're using the 7A13, the comparator, to center the waveforms. We have to do it for the triangle wave, the sine wave, and the square wave. So set it up in the positive to the center peaks, flip the polarity, and then you adjust the control to bring it down. Or you set it up for the positive, flip the polarity, then you adjust it on the negative side to center the waveform correctly. So we'll go through that here real quick. Positive peaks, adjusting it right to the center line. Flip the polarity negative. Now I have to adjust the control on the unit so the negative peaks are lined up at the center line. There we go. A little too far. Now we have to do a sine wave. Same thing. Adjust to the center line. Flip the polarity. then we adjust to the center line. And then we'll do the exact same procedure with a square wave. And the square wave's off just a little bit, needs just a touch of adjustment. And there we go. Okay, this is the 15 square wave compensation. So let me show you guys what's going on. This is, as I'm adjusting this capacitor, if I add some capacitance, this is not a sampling scope, so I'm having to do this with 100 megahertz digital. It's the best I've got in the lab for this, so this is all I've got. It's smoothing out that corner. I want to peak that corner up as much as I can, so we'll start adding some we'll start decreasing some capacitance. Make this faster, make this faster. Here we go. And right there, we're starting to get some fuzzing at the front end, and if I go too far, we'll start picking up some overshoot. So what I'm tuning this for is the best value without the overshoot. So right about there. Okay, I'm all set up to do the dial accuracy, which is R1321. There we go. Just had to make that match what the front dial was. Nope, I messed that up. Dial accuracy is done at 10 to the 3. So there we go. Now we go to 10 to the 5. And we adjust C1714 for 2.0. And that actually finishes the adjustment procedure, so we are done with that. Well, thanks for stopping by the lab and checking out this update and calibration on a function generator. Not as fancy as some of the scopes that we normally work on, but definitely needed in this case to get this sweeping function generator working in the background. So now that I got this guy all repaired up and calibrated and ready to go, we can get back to working on the 507. So there we go. See you guys in the next video.